Okay, the quiz I told you about is right here. So before today, just let me know, select any of the words you've heard before, and it doesn't count if you heard it in the abstract. I'm just trying to get a gauge of how many people have heard of Clojure, how many people have heard of Datomic, and how many people have heard of Nubank. And if it's a pain in the butt, it does try to make you log in, we can just skip it. Oh, there we go. Okay, cool. Okay, cool. These are about the numbers that, as I've been on this conference circuit, that I've gotten when I've talked to people. All right, we have functional programming is, finish the sentence. Pain. Fun. For me, it's foundational, which is a weird answer, I think, for a lot of people. Easy once you get out of the parentheses. Correct. Fun optimal. Okay, now looks like let's go ahead and get this party started. So when I landed my first real big girl job as a software engineer, I joined a startup that had recently rewritten their entire code base from Ruby into Clojure script. They'd been working together a long time, and they were excited about functional programming things. And it was a two-pizza team powered by Reagent, aka React, which basically meant that I spent most of my time hunting down bugs in a reactive front-end system. Great for me. And it was a really interesting dichotomy because a lot of my foundation has been with functional languages. I have a very kind of weird story. And I'm trained in the Jedi art forms of immutability and composability and function composition. But I'm bug hunting in this reactive code base where the events namespace was over 3,000 lines, which is very atypical. And working in Reframe, which is a wrapper on Reagent, which is a wrapper on React, and this is before React hooks. It was the olden times. And my job was basically to manage this big old ball of pesky state. And at the time, I didn't even realize the irony of that, that they had just put me on the side effects. And since I'm a functional programming girl, you would think that this would be the thing that bothered me the most. Like I said, I was ignorant. I didn't know. It was actually our Git workflow that really cost me a lot of pain. So most people use the Git merge workflow. You can see you have all your history there. At this shop, we did a Git rebase workflow because they like to keep everything very clean. They all, like I said, they'd all been working together for a while, so there was no merges, no messy graphs. Every branch was rebased, squashed, rewritten, and then put onto main. And I get the appeal because it looks beautiful, but it's not just rewriting comments, it's rewriting history. And it was nerve-wracking to do every time I did it. It's because the thing is about me is that I make mistakes. Do y'all make mistakes? No? And especially at the time, I was guilty of, accidentally formatting the entire screen and committing white space changes. And knowing that's a sin against, that white space changes are a sin against Cthulhu, whenever I made a oopsie, I ran a very dangerous Magit rebase interactive, which, side note on that, why I was year zero programmer, Magit rebase interactive, who let me do that? But all it took was for me to get distracted or to snack or for anything to backfire. And I'll admit that some of my, the worst tears of defeat have been shed during those times, during Git cherry pick, interactive rebase, horrible situations, just trying to salvage history and not look dumb in front of my new colleagues. And so, you know what, let's have a round of applause for the Git wizards on all of our team, because we may be too scared to admit it, but we all have a Git wizard on our team that will hit up in the 3 a.m. to save us, and you won't talk about it because you've been programming for years. Of course you know Git very well. But it made me be grateful for the person on my team. So it turns out what I was doing with Git, trying to rewrite history in place, it was mutating state was exactly the thing that I had been protected from, having used functional programming languages since the beginning. And, okay, so what does this have to do with databases? Well, as it turns out, Git is a pretty good metaphor for programming paradigms. When you use merge commits, you're preserving the full shape of what happened. History is persistent. You create new values and you don't destroy the old ones, and it's additive, append only, and that's a value-oriented model. And when you rebase, you're rewriting history for the convenience, for prettiness. You're mutating commit identities and you're discarding history to make things look nice. And you know that thing when you start to notice a pattern and then you start to see it everywhere, or you hear a new word and you're just hearing it everywhere? Value versus place orientation is something I'm starting to see everywhere, kind of like simple and complex and immutable and mutable. So many technology paradigms fall into these categories. And most programming tools are place-oriented by default. It was actually really hard to find an example of a value-oriented system that we were all familiar with. Git is pretty much the one. So why do we use databases? Well, we're trying to reflect a copy of the state of the world. And that state of the world is reflecting human actions. And once upon a time, we had very limited resources. And so we had limited disk space. But it's different now. It's 2025, babes. We got disks on disks on disks. Amazon will take all of your money for as much storage as you want. But I wonder, since things have changed, why people have stayed complacent. So I want to consider one of the most powerful data systems. It's the human brain. I searched brain. That's a book I wrote. It's a head. It has nothing to do with what I'm talking about, but I use the image because it's kind of related to brain. So our human brain, it stores and accesses and loses an enormous amount of data. And right now, everybody in this room has a back process running of the things that they have to do, their to-do list, right? It's like half cached in your head, half in Post-it notes in your office or on your fridge. And let's say that every week you meal prep your lunch soup. So when your friend gives you her mother's gazpacho recipe, your mother's gazpacho recipe doesn't just disappear. It doesn't just replace the same place, right? You make a new lunch soup every week, but it doesn't take the place of the lunch soup. Like, you don't forget all the soups you've made before. It's additive. So you get the recipe, it's exciting, it's new to you, and your brain adds it, and it associates it, and it appends it to your mental record of lunch soups. So we are all in this room because of our big brain capacity to solve problems, or at least your ability to convince someone with money that you can solve problems. And the difference in our tooling, at the core, most of our strategies are our tools, right? You can like pry my Emacs from my cold dead hands type of thing. And because difference in tooling can really make or break an experience. But at the end of the day, we're all different and we all like different things. So these concepts of, we don't want to talk about things that are easy, right? Because that's relative based on your experience. So, let's see. Same thing with concepts of good. Good, you can't say good tooling, bad tooling. You know, we can have bad experiences, but it has to do with what we've done before. And I don't really think those things are worth talking about because no other person can claim what's easy or good for you. Today we're going to talk about some tools, though, Clojure and Datomic, that some people find delightful and some people are terrified of. I think it's the parentheses, as somebody said. And the thing is, it's not really about the tools. It's about the philosophy. It's about the design. It's about the why. It's about the problems that caused these smart people to think that there's got to be a better way. There's got to be a solution. I've got to figure this out. This is almost perfect. And those, to me, are the interesting things worth talking about. So I'm not trying to convert you or get you to sign up for anything. I'm not trying to sell you, maybe a little bit. But so Stu Holloway has a really great talk. It is Sherlock Holmes consulting director. And he frames the code base as a crime scene and Sherlock Holmes as the gold standard consultant. And he says the important thing, this is being sarcastic, kind of making fun of us. You need tools. You need lots of tools. They need to be shiny. They need IDEs and build tools and note tools and debuggers and frameworks. And that's pretty much all we do around here is tool-driven development. And that's true to a certain extent, right? But he makes the point that with Sherlock, he is a tool user, and he's a really good tool user. And apparently, he didn't know this until researching the talk, Holmes is the first character in fiction to use the magnifying glass as a detective. And that's very indicative of the type of tools. You want to use simple tools, things that are ergonomic, things that get out of your way but still help you, things that help you see things. You're not looking for anything big or fancy or shiny or complicated or enterprisey. You're looking for something lean and general purpose. And even though Sherlock does use tools, and he uses other tools as well, the thing that stands out about him is not that he has more or better or shinier or more expensive tools. It's that he has a small set of tools and he uses them very well. Because your tools should be simple, ergonomic, and they should get out of your way. So now is when you would think I would lead into, and we have the best tool ever, and this is how you can buy it. I'm actually going to clarify that right now, because you see we have a sponsor stand, and we're talking about an open source language and a weird database that maybe you've never used. And it's natural to wonder, okay, what's the motivation? Am I trying to sell you something? Is this consulting? Am I building a product? A SaaS DB? Do we need open source commits? A storage layer? Actually, ironically, we don't deal in disks. We abstract out the storage layer. But just to put it all out there, I'm not here on any sort of commission or to sell anything. Maybe shamelessly promote my nonprofit learning group, but that's about it. Clojure is a programming language that is open source. It's used in production systems worldwide. It's mature. It's stable. They're probably not going to merge your PRs. I hate to break it to you. And then its spiritual counterpart is Datomic. Datomic is an immutable, time-aware database, and it's free to use. When I say I work on the Datomic team, so when I keep saying we're not trying to sell you anything, it's free. We can't. If you give us trouble, maybe we'll start charging you. But both Clojure and Datomic were created by the Cognitect, is a consulting company behind Clojure. And then in 2020, they were acquired by a Brazilian neobank, Nubank. They are the largest independent bank in the world. Pause and think about that for a second and what they had to do to get there. Nubank was created out of a desire to simplify banking because banking was broken in Brazil. Interest rates commonly exceeded over 100%. It was so hard to get any lending, and that's a real burden, right? And Nubank changed that, and they were able to do that because they built using our technologies. So once they found a little success, they acquired us because they wanted to steward the technologies and make sure that they stay safe. So I work on the Datomic team. A couple of my colleagues are in the room. Carol is here. Wave, Carol. Where's Aldo? Somewhere. On the very back. Hi, Aldo. And so our goals are to help developers be successful using Datomic. And since the acquisition in 2020, a lot of those developers are in Brazil. I have a different purpose, though. I was hired to increase external awareness of Datomic. And we're also joined by somebody from the Clojure team. Christoph, raise your hand. Yeah. That's the person that's here to increase awareness of Clojure. The numbers are already in your favor. Let's see here. Okay, back to Datomic, though. We did the Once Upon a Time. This is Cognitech joins Nubank. Oh my gosh, simplicity at scale. It's almost like I stole the name of the talk. Okay, this is crazy. I'm going to let you digest this for a second. This is our famous, I feel like they can just sign my paycheck with like this GIF. So in the Stack Overflow, our single mention was most loved, and then all the way down, least known. So I feel like my work is very much cut out for me. Let's see. So contrary to popular belief, this isn't a vendor pitch because I'm not trying to sell anything. We covered that. And I'm actually not trying to get you to change your tools or sign you up for anything or rewrite your stack. And I'm not here to bash any other language or any other database or make anybody feel like they're doing it wrong. Unless you're vibe coding, then you're doing it wrong. But wow, not even a chuckle? Y'all are killing me. Thanks, Carol. Thanks for the laugh. Nothing, just. So I'm here because I love connecting with people, and I love events, and I love niche, weird nerd stuff, and y'all are the only other people on the planet that apparently like that stuff too. And, as far as business impact, I said my goal is to increase your technical awareness. And I really just kind of want to nerd out and info dump to you about all the great philosophies that we have and like the problems that we solve. Because I want you to just remember that these tools exist. So that way, if you do come across these problems, you have that first, you're like, wait a minute, I think I know the solution to this. And you have a chance to evaluate it then, right? Like my goal isn't to immediately get everyone in this room to go and download Datomic. I actually did, I told my manager that would be horrible. I feel like that person would not have very good judgment. 10 minutes of a talk and you instantly adopt a tool? I don't know. So, since Clojure is kind of the big brother to Datomic, we are going to start with, this is one of my favorite images. This is in Effective Programs, 10 Years of Clojure. That's a talk by Rich Hickey, the creator of Clojure. And he actually had no intention of being a programmer at first. He wanted to be a rock star, a musician. And if you ever talk to him about it, he has just as much opinions on music as he does about programming. Surprise. And as the lore goes, Rich originally learned programming as a means to an end to move MIDI files around. And then after finding success in the industry, years later he was working as a software developer and navigating the same issues a lot of us faced. Mutable state causing frustrating, hard to reproduce bugs, concurrency becoming essential but still difficult and error prone, nobody really figured it out yet. Endless boilerplate code in languages like Java with inheritance hierarchies promising, OOP promises you reusability, but I'm not convinced that it actually delivers on that. And it just adds additional complexity and doesn't reduce it. And around this time, Paul Graham's essays on Lisp were making waves, and Graham explained really well how Lisp's flexibility and power gave him a competitive edge. And he described Lisp like a language that wasn't tied down by conventional programming constraints, and it allowed developers to be free and think and develop differently. And that inspired Rich. So enough was enough. He took a chance. He took his retirement savings and took a 2-year sabbatical funded by that, where he just allowed himself to work on the problems that he thought were the most interesting. He actually did not create this graph then. That would have been really on top of, but he's since gone back and realized that these were the problems that were irking him that he wanted to address. And so that's in 2007, he released Clojure, dynamic functional Lisp for the JVM, so it's hosted. One of his priorities was distribution and making sure that it could be used in production systems. And it really had it designed at the forefront with things like immutability, simplicity, and interop at the forefront. So the ones in green here are the ones that he set out to address, right? There's nothing that we can do about domain complexity. That's just life. Same with misconception and miscommunication. The hardest problems are people problems. Most of us probably know that. However, the ones in green, he thought those were, we could tackle those, right? He thought he could make headway on that. And he did. A lot of what we're going to talk about today is PLOP, the place-oriented programming, because that's influenced Datomic's model a lot. Rich was actually very heavily inspired by, who knows the RFC protocol? No, RDF? RDF? It's a protocol for metadata, it's an internet protocol? No? Huh? It's RDF or RFC. Okay. So, in order of importance, these problems are where he believed that we could have impact. And a foundational pillar of this model is immutability. This is our first philosophical nugget that I'm going to share and hope that permeates out in the world, and that you think one time you have a problem, maybe a null pointer exception, and you think maybe immutability is the answer. So immutability is the idea that instead of updating things in place, you can build systems out of persistent values, data structures that preserve their history and they can't be changed, right? When we used to take notes before we had erasers, right? Went down in the tablet and we just added another tablet if we need to take notes. And it's this shift from mutation to values that unlocks clearer reasoning and safer concurrency and more composable code. And it's this foundation that really everything else in the Clojure ecosystem is based on. Like I said, with that plop and place-oriented programming and value-oriented programming, immutability is the key concept there. Let's see here. So we talked a bit about value-oriented and place-oriented programming and how immutability fits into that picture. Clojure gives us immutable data structures in memory. We kind of did our Clojure, it's so related, we have to go into it for every Datomic talk. But what happens, Clojure gives you those models. What happens when you need to persist them? That's where Datomic comes in. Because most databases, they're not value-oriented. And that totally just boggles my mind that everything is place-oriented by default. Everyone's just mutating things all over the place and can be confused why no software works ever. You make an update and you update rows in place, you update tables, you overwrite data, and then if you want to know what the value used to be, you better hope someone remembered to log it, because if not, you're out of luck. The thing is with Datomic, the database itself is immutable, and you never update facts in place, you add new ones. So each fact is a datom. Sorry, I'm having some, here we go. So this is a datom. Look at it, digest it, feel it, embrace it, love it in your soul, because this is what allows you to look over the history of what you've done, right? This is the data model. With Datomic, the database itself is immutable. Again, you never update facts in place. You always add new ones. This has entity, attribute, value, transaction, and time. And so an example here, say you did this. Looking like SQL? looks harmless. Do we think it's harmless? Except then you start to think, who made the change? Was it applied correctly? How do you audit it? And you can certainly build all these logging layers and observability layers and buy all these SaaS products to help you recreate time. But the thing is with Datomic is that it's just built in. You just get it for free. It's been really cool to talk to people that have used it on their small projects just to get started. And they didn't even realize all the things that they get for free. Things like analytics, right? They went in to go put in all the tracking, and then they realized that every single user interaction just existed in a log. Like, they didn't have to do any extra work. Because the system is append only, it behaves more like Git or like a ledger than like a table that you'd scribble numbers into. So when someone changes an account balance, like Nubank is a bank, when someone changes an account balance in Datomic, you're not changing the past. They're adding a new fact to the timeline. So you can always go back. You can ask yourself, okay, what did the state of the world look like at, last Thursday at 3 p.m.? And we can answer that exactly because the database is a value, and every transaction is just a function acting on that value. But the value itself doesn't mutate. So it's immutability at the storage layer, and it's really powerful in domains like fintech or health, where correctness is absolutely imperative. You cannot just lose somebody's bank information. Same with health data. You really don't want to, when it's really important not to screw up your data, that's one of the contexts that Datomic shines. Okay, here's an example of how the entity model, you would create an entity. I'm Jordan, and at one point I had blue hair, and then I added my name there, and all over time I can see, inspect, observe everything over time. Actually, this would be really nice to see my hair color over the last couple of years. To have a log, that would be interesting. So Datomic is a database, and it thinks like a functional programmer. It treats facts as immutable. It models time as a core concern, and it lets you compose logic declaratively, and it, again, turns your database into a value that you can play with, you can reason about, you can poke, you can observe, and it's relatively risk-free because you're not messing around like in your production data. So when you're working in fintech and you can't afford to lose state during an incident, and you can't afford to rewrite history because the regulators won't help you. Banking is a regulated industry, and what that in compliance code means that if you screw up, you're not just getting like a bad performance review. Like, you could be going to jail, and that's heavy. It's nice to have a ledger to be like, hey, I didn't do that, or hey, I did, I should go to jail. So immutable storage makes all these things easier. You can diff between database states. You can answer questions like, what did we believe to be true last Thursday at 2:49 p.m.? What did we believe to be true last Thursday night? And you can diff that very, very easily. And so you build systems that make auditability a feature, not a burden, because it's built into the data model. And so we don't have to reinvent burgeoning, we don't have to change tracking or historical reads, because those are just like native, they're just built into a value-oriented system like Git. It just comes with it. So you could take a snapshot of your entire database. Like, imagine if you could take a snapshot of your entire database, not just backup, but a complete addressable value that you can query, compare, and replay at will. This was the 3 o'clock on Friday. Well, with Datomic, that is literally what is happening. It is a snapshot in time that is exactly the same. It's not a ghost. It's not I guess it is a copy. And that's what immutability is. Hopefully, by the end of this talk, it's great if y'all are tired of hearing about immutability. I think I did my job well. So you don't need to simulate history. You already have it. And it's something you get for free. So think about compliance, we think about debugging, we think about incident reports, and why immutability might be valuable in those contexts. Let's say that you're debugging a support ticket. Customer says their settings totally changed unexpectedly last Friday. In most systems, your options are pretty limited. You can grep logs, you can hope the audit trail is complete, you can hope the CI/CD did something, you can hope that great Git wizard coworker can roll something back or something. But like I said, in Datomic, you can say 3 p.m. Friday, let's see it, and it just pops it back. And that's a superpower for incident response. And it also makes testing easier. You can write tests that replay real production timelines and assert that the system still behaves correctly. So a lot of Datomic users can run isolated in-memory test databases and then load them with test transactions. There's a lot of blogs and stuff on this. Essentially using real Datomic behavior in tests instead of mocking. And this gives you very realistic tests with predictable data and no database side mutations. And then combine that with observability of a REPL and Clojure, which I do not have time to get into, but hopefully one day you do. Those are really, that allows smart people to build big things pretty quickly. So another thing about immutability is that it reduces the surface area for blame. In mutable systems, like who's ever gone into Git blame? Who did this? It was me. I did it. And in mutable systems, the state changes get lost, and when things go wrong, it's easy to point fingers, like on that rebase thing. Say there was a bug, two people merged on the same time, you wouldn't know. But with an immutable database, you can always trace what happened, not who you think made a mistake, but the actual transaction history. And this builds trust in the system, in the data, and across teams. And once you have that trust, you can evolve faster because you're no longer afraid of breaking something that you can't undo, or doing something that you can't explain, because you always have that context of history, that context of meaning. So immutability in a database. It means that you don't overwrite, you add, it's append only. It gives you a complete, queryable, auditable history. And that's nice for so many reasons, but testing, debugging, incident response, trust amongst your team, I think that's why Clojure is commonly one of the highest self-reported programming language, also like highest paid, like most loved, highest paid, when they let us into the Stack Overflow survey. So in regulated high-stakes domains like fintech, again in health, it's not just, all these things aren't like a nice to have. It's essential. It's something you have to think about from day one. And one of the points that I'd like to share with you is that if you put in the thinking time up front, then you can and you choose tools, simple tools that get out of your way and also are able to scale, then you will be like handsomely rewarded. And like I see it when I run groups. People come, I was just doing this as a learning project, and I have all these analytics. And it's a very different model than what most people are used to. And it's weird for me because it's the only thing I'm used to. But once you see the value of treating your database as a value and not a place, you start to notice all the ways that you can decomplex, all the ways that you can pick things apart, all the ways that you can have these separation of concerns that we know build robust, maintainable systems, right? The human brain cannot keep track of that many things at once. So the more complex we make our software, the more bugs we expose ourselves to. So we talked about immutability, and the next one is composability, function composition to be cheers, Christoph. This allows us to build clean, testable, observable pipelines. So if immutability is about preserving information and making state reliable, composability is about the logic, right? We have immutability for the state, and then we have composability for the logic. And that also abstracts it out and makes it easy to reason about and easy to understand and easy to compose and reuse. At the core, composability just means building programs that combine small, focused functions into larger operations. So functions become your little building blocks, and the composition is how you assemble them. When I was learning, I had a few like rules that I would fall back on if I got stuck, and one of them was, when in doubt, abstract it out. If I was working on a function and it was getting too saucy in there, I would just start pulling out all of my anonymous functions and naming them and writing doc strings and being really annoying about it just to force myself to think through everything. And that's one of the benefits of composability is, like I said, our human brains, amazing, but also not great, right? We can only balance so many things at one time. And the smaller pieces you have, the easier they are to manage. And for big brain people like in this room, you can get a lot back with that efficiency, right? So in a lot of systems, as I understand it, business logic will be buried in large functions or spread across objects with immutable state and side effects, and it becomes hard to understand what is happening when. I think my closest experience is probably JavaScript callback hell, where trying to bootstrap a web app application when one thing would cause one thing, and then, like I said, before React hooks were a thing. And I think that's personally my only experience. But I understand, apparently these are very big issues. And they go up to what they call the tar pit or a mud ball. You end up with a ball of mud, tightly coupled, brittle, difficult to change. We hide behind technical debt. And when we look at our data flow from the database to the API to the UI, it becomes a tangle. That word I said, complected. It becomes complex, when something gets in a knot. And that's what all of our software systems look like without immutability and without composability. So functional programming kind of tackles these with two core ideas: the separation of concerns. So with Datomic, querying, transforming, and effectful operations are distinct. We'll see an example of that in a second. And like I've been talking about, functional composition, when you can abstract out your logic and reason about it in tiny pieces, it makes you more powerful. It's like transformers for your logic. So let's think about how Unix shell commands work. Each part of the pipeline does one job, and then it passes it to the next. You can insert, you can remove, you can reorder components easily. And functional composition, this is an example of functional composition what we do in our code. And Datomic supports this pattern really, really well. So we have a to-do list app tutorial that Aldo made. And here we can see how everything is in it's separated by separation of concerns. We can see that fetch to-dos is about querying. Even if you can't read the language, just put a black box around it. You got this, big brain people. Normalize to-do is about shaping data, and then in the end, we compose them. But then it makes each piece, again, easier to reason about. It makes each piece reusable. I've been a part of some really great veteran Clojure software teams that have amazing kit libraries that they've been using for math and money and time, and it goes beyond they're making their own macros and stuff for this, right? And a lot of that is because of value and composability. So here we have separate concerns, and it makes the code readable. Each function says exactly what it does. It makes it reusable, that we could normalize other queries too, like normalize to do can just work. It's testable. Each piece can be tested in isolation. You can see what went wrong, why. And it's observable. You can log inputs and outputs in between steps. And because each function has inputs and outputs, adding observability becomes trivial. No mocks, no magic, just data flowing through the functions you can throw in. I like to do a def test or if you can console log something if you're doing Clojure script. So at Nubank, in the abstract, I said so many numbers, right? We certainly have a lot of numbers. That over 4,000 microservices, and we have a bunch of small autonomous teams, and things like consistent patterns like function composition that Clojure and Datomic enforce by nature, right? I was told another user story about Datomic is that there's a null pointer exception. They were running into this thing, it was crashing their, it was 3D rendering project. And they came to find that they knew immutability was the way to go and started using a different functional language. And what they found is that people just wrote Java in Scala. And that was really frustrating. But the thing is about Clojure and Datomic is it actually completely prevents you from doing that, because it's really common for a lot of people. If you know something as a first language, of course when you learn something as a second language, you're going to, that's what you know, that's what you copy. But Clojure and Datomic don't let you have as many bad habits. So when everything's built out of small testable pieces, you can experiment and you can refactor safely. Onboarding is way easier. Failures become easier to trace. Logic is easier to simulate and validate in test environments. It's just safer overall. So composability isn't just a fancy word, and it's something that Aldo and I kind of worked hard over the last couple weeks to try and describe, right? Because I know the feeling. I know the feeling of making all these different reusable components and then being able to interact with it with the REPL and see the data. But it's hard to communicate that to someone that's never had that feeling before. So composability is small functions that are composed into pipelines that allow for separation concerns, better testing, observability, reuse. And Datomic's architecture encourages clean boundaries between all of these separation of concerns. So let's go back to that Git story. So I was trying to save face, clean up my repo, make things tidy, hide my mistakes. And every time I tried to squash history into something pretty, I lost something important. I lost meaning and I lost context. And the more tangled things became. And that's the cost of mutation, of using place-oriented programming, of rewriting things in place, or rewriting and pretending things were never messy in the first place. It's kind of like when they go into a bad part of town and they do a quick fix and turn the houses into HD TV, but they don't actually fix the bones underneath, right? Your code base is like a house, and if you don't actually address from the very beginning good architectural patterns, it's always going to be a lemon underneath. It's always going to be a dud. And Clojure and Datomic kind of prevent you from doing that, which is nice. So if you're mindful about the tools that you use up front in a project, it really allows for easy scaling later. And on this path is choosing tools that are, in my opinion, I'm not trying to change your mind, choosing tools that are value-oriented instead of place-oriented. So of the key takeaways, we have immutability gives us stability. By preserving past states, we gain observability, we gain testability, we gain clarity, and it's really essential in domains. Like I said, we can't get rid of domain complexity, but we can do what we can to help our human selves in dealing with that complexity. And so observability, testability, and clarity is really essential for scaling systems that can't afford to screw it up. Information systems. We also know that, so immutability gives us stability. composability gives us flexibility. When we are mindful about how we create something and we design in these small, pure steps, then we can build robust, reusable pipelines, and we reduce accidental complexity. When we avoid things like side effects, less things can go wrong, as it turns out. And Datomic and Clojure embody these principles, both as a database and like Datomic as a database and Clojure as a language. They encourage a mindset that makes systems easier to reason about, easier to debug, easier to extend, easier to scale. And we know that's true because of how successful Nubank has been. To the largest independent bank in the world, we have some of the best cost to serve in the entire industry. It's more than 50% better than our competitors. And so I'm not here to convert you or tell you to rewrite your stack, because not every tool is designed for every job. And I get it. This is foreign and scary, and Lisp people are weird. Fine, whatever. I'm weird. It's true. But I will say, we do actually have Babashka, it's in Clojure. We have Babashka, which is the scripting language. We have ClojureScript, which compiles to JavaScript for the front end. We have Clojure, which is hosted on the JVM. And then we have some really sweet Python data science integrations called like libpython CLJ. So not every tool is for every job, though, at all. So again, I'm not trying to get you to change your mind. I just want you to remember, when later on, if you are experiencing, it feels like you can never catch up to the bugs in your system. If your system feels brittle, if you are constantly rewriting logic that I swear I solved this last month, right? But you can't tell where the actual bug is coming in. Do you spend more time maintaining code than building features? These are the times, maybe, like, what did that girl purple haired say that time about immutability? And what were those languages? Clojure? Yeah, other ways exist. Other people are building scalable, resilient systems and using value-oriented programming. It's not out of date. So when you find yourself debugging a production issue at 2 a.m. or putting in custom analytics trackers on every UI interaction, and you're thinking, like, why can't I just see what the UI, why can't I just see what the state looked like yesterday? I hope a little voice says, Clojure, Datomic. And here's a meme I made, but I'm not trying to convince you to change tools or anything. Okie dokie. So if you want more information on me, that's my everything. I don't know, Blue Sky, LinkedIn, all the places. There's like so many places. There's so many places. If you want the Datomic Must Watch, this is a YouTube playlist that we put together with a lot of really good Datomic content. And if this did pique your interest and you want to experiment, that independent nonprofit learning group I helped co-found about 4 or 5 years ago for Clojure and Datomic. It's called Clojure Camp, Clojure.camp. And we're super into experimenting with learning. We do a lot of mob programming, a lot of pair programming. We have a mentor matchup system. The last Thursday of every month, Aldo and I run a session called Doing Datomic, where we get all the tooling and everything set up, and then we all go and we share one guacamole server, so you can just show up with nothing installed and just play with Datomic for a couple hours together with friends. So, yeah. Oh, look. Oh, I'm done. Yay. It was this it was this clock, right? I think I was looking at it. All right, class dismissed. Unless you want to keep looking at memes. Does anybody have any questions? I mean, do you have any questions? You're standing like you have questions. I would answer them, but y'all are such a tough crowd. You're smirking a little bit. You're the three of you are awesome. Thank you all for showing up. Come talk to us at the booth.